Another key which is not selected as a primary key can be secondary key. Still, using secondary key, you can access the data, find the data, you can find the unique data. It's a very nice way. Okay, even though we have two doors in the classroom, I know we have one in this classroom. So this one is a primary door. Still, we can use the secondary door. Using secondary key, we can find the data very, very efficiently. So we will eventually create secondary index in database. What's an index? We will discuss it in the later part of the semester. What about the primary key? When you assign this one as a primary key, automatically create index. Okay, what is an index? What is an index? It's an index card to learn the vocabulary in your elementary school, right? Have you ever used the index card, fresh card, like to memorize the spelling or whatever? So index is the something very well organized data structure for what? To find the data very, very fast. How can we do that? Because keys, words are sorted by alphabetical order. If data are sorted, how can you find the data? You can use a binary search. What is a binary search? Cardinal half, cardinal half, cardinal half. Complexity? Log n? Log n. Okay? It's a very efficient way to access it. Is it n log n or n log n? It's log n.
It's log n
Linear?
because it's constantly cutting. It's log n because it's constantly cutting.
Oh yes, it's a cardinal half. So we can use the binary search to find the data using index. So primary key, what does it mean primary key? It's a non-null and unique. How can you check the uniqueness? The data should be sorted. Then find the data. So when you create the primary key, automatically create the index. When you create the secondary key, it will create the secondary index. We will see details later. Then the next step is that so far we discussed most of the thing in the ER model, but not in super and subclasses. Enhanced, extended model. So we will talk about that. How to convert, how to handle extended or enhanced. There are different options to handle super and subclasses. First option is, as you can imagine from this example, we have how many entities do we have? Entity. How many entities? One entity. Okay, don't be confused. This is a super and subclasses. And how many subclasses? 3 subclasses. How many superclass? One superclass, and this is I'm not sure whether this is the disjoint or the not overlap. It's not sure, but that's not a big problem when we convert this one. So we'd like to convert this. The naive way is what? Create one table for employee, one table for secretary, one table for technician, one table for engineer. Okay? Yes? So we will create one table, one relation for each class. Even though we have one entity, but we will create one by one. For example, employee. Employee. SSN is a primary key, and so on. Then, secretary, we have typing speed, and technician, we have T grade and engineer ENG type. What we miss? There is primary key. Each relation must have one primary key. This one has a primary key, but this one does not. What is the primary key of secretary? Social security number 1 automatically enhance all attributes. So do I need to mention name, birthday, address, job type again? You don't have to. Why? Instead, you can create the foreign key that remove the redundant information. We don't have to keep the same information to both. Instead, we can create the foreign key. Similarly, SSN to here, SSN to here. That's the first option. So first option, when you have the sequence of classes, you can create one relation, one table for each class, and create the foreign key from subclasses to superclass. That is the first option.
Excuse me.
Yes.
Without this definition, overlap or
Yes. This time it doesn't matter. For example, if this is overlap, there is a secretary 111, and there might be secretary technician 111. It doesn't matter. As long as you have 111 in employee, you can create. There is no problem. Okay, so this is the first option. Second option. We can create a relation, one relation, only for subclass only. Okay, so option 2, subclass only. In this case, secretary. What is the key? Primary key. SSN. Then typing speed. Then first name, last name, middle name initial, DOB, and address, job type. Next, technician. SSN. T grade. First name, middle name, last name, middle name initial, DOB, address, and job type. Engineer. SSN, engineer type, first name, last name, middle name initial, address, DOB, job type. What about the foreign key? Do we need the foreign key each other? No, there is no foreign key constraint. Okay? Because we remove employee entity, employee table. Okay? So this is the second option. When do you need second option?
I think overlap.
It depends. It depends on what? Which case?
That income table has any relation with other table or not?
Okay. Yes. I know. When we design like this, in this case, generalization. The designer of the logical modeling who built the ER diagram believe from secretary, technician, engineer, generalize into employee to reduce the redundancy. However, when you design the database, you analyze the application. All application accessed separately. Only secretary, only technician, only engineer. Not each together, like the employee. At that time, you do better, keep you'd better create the relation for third class. One. Also, this one is a very strong constraint. Okay? Whenever you hire engineer, there should be exist on the employee. But your database is not such a strict. That time, this one will be possible. But most of the case, this is more the popular. Why? Because when you design such a super and sub classes, which means they are employed, okay, commonly. However, during the designing process, you can go to the second option also. The next option. Anyway, how many entities? One. So, do I need to create a separately? No. So, I decide create only one employee. What is the primary key? Social security number. And first, the first name, last name, middle name, initial, birth of day, and address. The next is we need to include secretary, technician, engineers. Okay, so how can we, if this is a disjoint job time. Okay, so one of them. Then add all attributes of subclasses, which means typing speed. Next, T grade and engineer time. So this is a key point.
No.
Yes, in this case we have a lot of noise, but still simpler than this. When do you need this one? First, it should be disjoint. Okay. In case of overlap, you cannot represent the multi-value here. So no way. So disjoint. Also, if in case most of our application access not separately, only as one employee. At the time, this one is correct. So this is the third option. What about overlap? Overlap means employee can be secretary as well as technician, also as well as engineer. They cannot be represented by this option. How can you address the problem? Think. One, employee. Primary key, SSN. Then same thing. First name, last name, middle name, initial, DOD, address. Okay.
After I use anyone to be, I'll call it job. The job will have job ID, will have property, and the property value. That's it.
So you can ask for each, right? Whether this employee is secretary or not. Yes or no? It's a Boolean data type. True or false. Is this employee secretary or not? Okay? Similarly, and technician, whether this employee is a technician or not, true or false. Also, whether this employee is engineer or not, true or false. And add attribute, typing speed, T grade, type, engineer type. For example, 111, first name J, last name V, middle name initial K, and 848, 2000, address Secretary?
Yes.
Yes. Typing speed 100 words per minute. Technician? No. Then this one will be none. And engineer? Yes. Engineer type, the mechanical engineer. What about the next? 112. Secretary? No. Type speed? None. Technician? Yes. Technician? Grade? The high? Y? And software engineer. You can use such a way. In case what? Overlap. So this is another way. So you need to select one of these when you convert ER model to the relational database. Why do we need to convert to such a thing? Because relational model is not very flexible. We cannot represent object-oriented concept. Even though the super and subclasses are very useful for logical model. Okay? But which is not good for relational database model. That's one shortcut in relational database model. Okay? Only atomic, there's no super and subclasses concept. We need to select one of these. The problem is, what if we have another super and subclasses over here? That's possible. We have seen the huge size of super and subclasses. Person is one entity. What about this? We can consider separately. So select one of the option for this, then select one of the option for this. Okay? So to show that example, okay. So this is the first option. First option for each. Don't forget, we need 40 like this. What about this? From here to here, which options are used? This is second option. We have subclass. One relation for subclass, another relation for subclass from these super and subclasses. So both of them has the vehicle ID, but there's no foreign key each other. For this, third option, job time and typing speed, T grade, and engineer type. Okay, this is third option. And last option is we can, in this case, part. This one. Part, manufactured part, purchased part. So we are going to ask whether this is the manufactured flat, yes or no, and purchased flat, purchased, yes or no. That is will be useful in case this is true. This will be used in case this is true. What if multiple inheritance? Like this example. So this is the one entity, as you can see. We have one super subclass, and another one, and another one, another one, another one. For each, we need to select the option. So your homework is, this is one of the example. Okay? You need to decide which options are used to convert that one into relational model, relational schema. One, I will give one of the answer. For example, the first one, person employee, alumnus, the student. Person, employee, alumnus, student, which means first option for this option 1. Just like that, decide the other option, which is used for this relational database schema. Okay? As you can see, option 1 will not be used more, right? You can see only this. Oh, there's another foreign key, which means option 1 is used also. This is the first homework. Another homework is convert this ER diagram to relational database schema diagram. Okay? Do we have any super and subclasses? No. In this case, no. So you don't have to worry about it. Just follow the step. The problem is this is ternary, but in this ternary relationship is weak entity. You should be careful. Weak entity means there's no primary key, so you should borrow the key of identifying. Which one is identifying? This one and this one. So S name plus this also weak entity. So you need to find referencing. So name plus P name is the primary key of port. Then name, P name, S name will be plus start date will be the vigit primary key. Something like that. This is very complicated. Okay. But let's try. If you can solve this problem, pretty much it's okay.
Converting to schema.
Yes. So two homework. One is this one. Another one is find the option used for this. The last one is the union type. Can you remember the union type that we discussed the last time? Union type is multiple inheritance. So a multiple superclass, like the bank or the owner of the car. You have different owner, bank, manufacturer, and yourself. Okay? You need to combine, inherit to the owner. Yes.
Give us more homework.
No, that's the homework. Yes.
And they give practice also.
Oh no, this is the another explanation. It's the last one, which is not used a lot. Okay. But for example, here, person, man, company, these are the superclass. It's not the popular. It's very, very used. Then inherit to the owner. So in this case, to represent the owner, no way to combine. Driver license number different. Bank name is different. Fee name is different. So in this case, we can create additional key. That's for the surrogate key, like the owner ID. Okay? Just like the sequence number that we create. Okay? In this case, it's not optional. You need to create the additional key. So you can create the owner ID for this. Owner ID, then owner. Then foreign key. This is called the union type. Similarly, you can do the vehicle. That's it. What time is it?